composition of functions. Here we're given with f of x 2x plus 3, g of x equals 3x minus 1. So here we are asked to solve for f composition of g of x and the reverse, which is g composition of f of x. Now, having this expression with the circle that is not a solid circle means composition. And this means that we're taking f of g of x. So what I'm trying to say is whatever your g of x will be plugged in as a value for x for your f of x. So if you have f of x there, so let's write that out, 2, and your x would be your g of x, which is 3x minus 1 plus 3. And then trying to solve and simplify. So 2 times 3x would be 6x. 2 times negative 1 would be negative 2 plus 3. And then combine like terms, 6x plus 1. So this is our composition of f of x and g of x. So in this case, if you're asked to have f of or f composition of g of x, which there is a value for x, let's say 1, you plug in 1 to x here, and it goes 6 times 1 plus 1. So similar to what we did in the previous section when we are evaluating those basic operational functions. Okay, so let's work on the second problem, which is g composition of f of x. That would be equal to g of f of x. So doing that, it's like you're trying to plug in your f of x going to your g of x. So what's our g of x here? It's 3x minus 1. So therefore you go 3 times our x. Our x now is our f of x, which is 2x plus 3. So we're trying to plug in 2x plus 3 to x of our g of x. Then minus 1. And then simplifying, multiplying 3 times 2x is 6x. Multiplying 3 times 3 plus 9 minus 1. Combining like terms, we will get 6x plus 8. So that would be our g composition of f of x. Now remember, we're using an empty circle to represent composition. So the period is symbolized for multiplication of functions. So that's multiplying. But for empty circle, it's composition. Okay, and that would be our answer. Okay, you can see that too. When we reverse that, you will have a different answer. Now here, if you're going to be asked about the domain here, it's all real numbers. So domain would be all real numbers, which is negative infinity to infinity. Since we're looking at a line here, which is a positive line because it's a positive slope, 6 there, and the line is going up, similar to the other function, resulting function from the composition. So the domain for both of these answers would be negative infinity going to infinity. So that's for the domain. Okay. Let's work with another problem. Okay, so let's have another example. We're given with f of x, square root of x, and your g of x would be x minus 2. Now you're going to be asked what is f composition of g of x. And then you will be asked what is f composition of g of 2. Okay, so first we're going to answer the first question asked. So we need to f composition of g of x. It's like you're bringing your g of x and plug that into the value for x in your f of x. So we'll just put arrow to represent that. So that is similar as saying f of g of x. Okay, so we're plugging that in. Our f of x is square root of x, so that would become now square root of x minus 2. Because our g of x, it's x minus 2 here. So we plug that in as a value for your x here. So this going here, it becomes square root of x minus 2. Okay, and that would be our answer. We cannot simplify that further. Okay, now you'll be asked what is f or composition of g of 2. So what we're doing here, we're just plugging in there. We already got this answer here for the composition of the two functions. We just plug in the value for 2. So the 2 here goes here to your x. So now I will say square root of 2 minus 2. 2 minus 2 is 0. So the answer would be 0. So f composition of g of 2 would be a 0. Okay, so that's the value. The alternate solution is, we still have the alternate solution, second solution. So if you want to do it in a different way, you can actually solve for g of 2 first, and then plug that 2 to your x here, 2 minus 2, that would be a 0 for g of 2. And then when you do composition, you do f of g of 2, then you're using the f of x. And then you plug in your g of 2 here to the x of your f of x. So it gives you square root of 0. And what is square root of 0? That is equal to 0. So still it gives you the same result. So that answer there is the same as the answer here. Exactly the same. So you got 0 there. And now, if you're going to be asked, what's the domain? So looking at a square root function, remember the domain here, this square root is function is half of a parabola that's facing to the right side. So it's actually, you're looking at the 0 and the positive values, yeah, going to the right side. And the domain would be okay, the smallest value you can have is 0 for your x here, and the smallest you can have for the composition of the two functions would be at actually 2. So if you will have 1, that would be undefined. So by looking at that one, so uh, you're going to check that by setting the radicand equal to 0, and it means now that is x is equal to 2. That's the smallest value that you can assign, positive value. And you can assign 3, you can assign 4, still defined. But if you assign 1 for x, try that. 1 minus 2, it's a negative 1, which is imaginary. So the domain, including the value, would be 2 going to infinity. So that would be the domain. Okay, so that's composition of functions.